How's it going, everyone? Eulier Gonzalez here again. Looking at the React Performance, which is a course taught by Steve Keeney, head frontend engineer at Temporal, this open source durable execution platform, pretty much like Kubernetes, but to cover a specific business use case. So, for example, like Versal, in which is something that I already use as part of my own dev agency as a way to provide my service to clients overseas. And the whole point of today's video is to now finally take out the React Dev Learn section as a way to now understand and make sense of the escape hatches here, as a way to not only be able to articulate and describe in a short and concise way how do we get here in all of these different topics, but also know how to actually put up practice that, how you can write applications and how you can now identify what are the main typical use case that it cover specifically here with useRef, useDev with the DOM, as well as effect and what effects are and what this is particularly and how this fit into the rendering mechanism from React, as a way to now move on to the next topics, which is all right now when we can use an effect and what is the life cycle of effects, following by separating effect from the event from the effects, removing effect dependency, and reusing logic with custom hooks. As a way to now, because this is also something that I'm going to build, is part of my landing page. This particularly web app that I want you to actually show as my presentation card to any other clients overseas, as a way to say, hey, this is what I have done, this is what is the company that I have helped or that I put my trust in, that, as well as how can now as well as now how can I showing my work. And actually, if you need me, well, you can contact that so you can actually manage it. I think this is also something interesting, especially when you need to hire someone overseas. And if you're going to pay that, you as a US citizen and following by the FATCA, so then you need to actually be compliant with the US tax law. So because of that, now enters into a new frontier of, yes, all right, people in the US need to actually delegate all of these systems, and that's a way for you to know how to manage them. And that's why a lot of people actually are having now WordPress or PHP or React application, also Angular, as a way to say, hey, I need you to actually maintain this application. What I can focus my attention is on the AI, for example. So most of the work that I'm going to receive, it'll be is for maintenance, do a house cleaning as well, and implement new features with this. So that's one of the reasons why, if you know where you're going to look, if you know where you're heading, and you put in, you do anything, and you do anything to improve that, to when that thing come up, you know what to do in the most effective, fastest way possible. If you don't do that, it's like, again, is your own. So, well, in this particular course, first we'll look at the importance of the performance and the goal of this course, which is how can we write React components in the most performant way, and also how can you now identify performance issues. And as a way to do that, we need to understand is this React mechanism, how these things actually make sense and works behind the scenes, as well as how can we now, for example, is how can we now, for example, how can we now, for example, is to well, so by understanding is that how these things work, how you can come up with some sort of solutions that I help you to identify these performance issues. And when you do that, now you can come up with some solutions, aka some best practice. So, broadly speaking, Steve Kinney say anytime you look at an application and they have some sort of performance issue, this is now part of the recipe that you must follow. And that is, first, look at the website, look at the live site, if they have using the production or the development bundle. Or also, if they're using it production, then take a look now at the React component hierarchy, as well as the state, and start from there. There's also some catching renders that they're using. Actually, take a look at what they're doing and how they are doing that as well, because that will help you is to identify these bottlenecks. For example, if that's not a problem, if you fix that, the other is, well, how now this React component is being loaded. So by deferring this in the long run, that's one. And second is, well, how you can is after you identify is using the use suspense API as a way to load things progressively, how you can now, if you're in a real pickle, well, use a transition as a way to defer some rendering that happened after that. So the TLDR and the value proposition of performance is that it is faster to do things. It is faster to not do things than doing stuff. And there's some corollaries to that. So it is way much faster doing things later than doing it right now. And with that, because after all we need to understand how the React works behind the scenes, well, I'm going to briefly describe from the Learn section of the React docs how these things work. So, after all, React is a JavaScript framework that allows to describe UIs. How can we do that? By writing is JavaScript function. We look at how can we import these functions, export these functions, or aka React components. How can we make use of the JSX syntax, which is the way of how now you can use JavaScript inside of or with HTML, all right? And how you can connect that using the curly braces, the JavaScript world with the HTML world, followed by how you can now pass props to these components through the inputs in your function, as well as how you can render conditional components, how you can render in list of components. It's important to put a key anytime you're rendering this as a list of elements, so React can keep track where this thing is going on. So pretty much like you have a folder and you have all of these files here. So if you know what file changed or what file was eliminated, you now have much more control of this and you can do some optimization, which is what React is doing behind the scenes. And also how important when you are writing your components that must be pure. This rendering logic, as they call, must be pure because it serves to a couple purposes. One, it allows you to now run these components in any JavaScript environment. So for example, servers, and given the same inputs, you will always get the same output, meaning that you will always, or giving a particular input, you will always return is the same JSX, which is helpful in server context as a way to serve this content to multiple users, many users. The other is this: you can catching this component using some memorization techniques, like use Mimo, for example, as well as now how you can is, when it comes to pass down data to the render tree, safely stop the execution and start it again. So the render tree is now the way how React sees your components as a way for any time you define all of these React components, you can, once you understand that how the things is done, you can look at how its data is passed through that, as well as which component actually are having some troubles, especially when rendering, or you have some performance issue. It is called a tree because this is a way of how now computer science organize data. This is the field of data structure. Data structures like of way of how you can organize your data. So you have is a hash, pretty much like a table, or I better call this the dictionary. You have the definition, the key, and the value. All right. The dictionary. You also have is arrays, which is collection of elements. How you can organize this. Okay. Pretty much like when you are in kindergarten, in preschooler, when you have now, for example, is, I don't know if you have that, but it's like the worm, or all of these cubes that is joined together, okay, in a way that contains some letters and some elements there. So this is a way of how you can organize your elements. It's an array. Another good example is when you look at the libraries, if you are able to see a library, or when you look at outside cards, when they're now organizing in a line, in an array, collections. Also, we look at linked list, list, stack, queues, tree is one of them, as well as graph. So that's why that's one of the reasons why computer science at Meta, they create this, or they use this tree as a way to represent this render tree, followed as the same as the tree dependency. So the tree dependency here, it's saying, hey, you know what? Sorry. The tree dependency here is saying, well, it'll be the way of how we can now share data across, or reusable JavaScript logic across different components. So instead of actually passing is a bloated code to the client, we only send the bare minimum instructions that is needed for this component. And this is just to describe is the UI. But when it comes to adding now interactivity to this component, we look at how can we do that with event handlers, using of course JSX, connecting a function in the JavaScript world to the HTML world as a way to listen to this event on click, for example, or any other event that are part of the element, part of this interface from the DOM, okay, as a way to now have access to this particular object, or this particular functionality feature, as well as now we were able is to look at how can we now show data with states. So states is a component's memory. Here with this state, we also look at how can we update our states. And when we update our state, okay, React now actually passed through a rendering mechanism. It triggered that mechanism. So as a way to actually update that state, and you can see now that state updated in your event handlers in the next render or in the next screen updates. So this process is made out by the trigger, what it detects when this happened. It can be at the initial element, the root element, or it can be as part of a re-render. It means caused by a component or any component or any ancestor that update the states. So when React know where it happened, it say, all right, now let me actually depend when that happened. If this was on the root element, I'm going to create all of these elements using the create function from the DOM. All right. If this was caused by a component known as re-render, well, let me now actually call that component that that trigger that state updates. I'm going to evaluate that, compute that it is props, it is states, and the event handler logic as well. All right, I'm going to store that information to be used in the next phase, and then the return of that component, which is a function. If this contains more JSX or more React component, then let me call those again, and I'm going to repeat that process over and over and over and over until there is no more components in a recursive way. So when he does that, now it constructs the virtual DOM here, something that we're going to talk about that later. So in the commit phase, which is now once we know what our elements need to actually apply to the DOM, the commit phase, if this was happening at the initial render, it's going to now append using the append API, append methods from the DOM API. I'm going to append all of these elements so you can now show in the browser panes the UI. If this was caused by a re-rendering, then because it creates behind the scenes something called as a virtual DOM, which is not a technology, it's just a computer concept that allows to represent the ideal representation of a UI and keep it synced with the real DOM. Okay, so with that, now we can say, all right, it'll make all right. Now it is time for us to apply only the necessary change through the reconciliation phase, and this reconciliation is using the diffing algorithm. React Fiber, which is now the reconciliation engine, it adds some properties or some objects, additional information to this virtual DOM that it creates, okay, as a way to make now those state updates or those synchronization with the DOM efficient, as much efficient as possible. The DOM detects those change, which is the browser, and then paints your application. This is the process of what is going on behind the scenes anytime that you state an update. And this is part of the core to lay the foundation of what's going on, not only for React applications, but also for the other frameworks that using behind the scenes is this virtual DOM. So for example, Vue. And now once you understand that, you will gain is much more broad perspective of what's truly going on then. So for example, when you want to state an update and what's going on during that. So during the rendering phase, where now state act as a snapshot on every render, where on the state value or the variable state updates will be the variable value, the variable state value update will be perceiving the next render. So it means that they are not synchronous. Those state updates, they are not synchronous. You need to pass through this rendering mechanism. And the other is that when you're going to set your state, which is on the event handlers, is in there where you can think that React fixed that state inside of the or during the event handler rendering. Okay, and also we look at how can we now is batch series of states updates. And how is useful, for example, when you want this to perform side effect inside of your event handlers. For example, things that happen outside of this function. Okay, whether with side effect is like perhaps you want to connect with other servers, for example, the timers. But it is quite interesting to look at that, and also is something that is not that common use case, depending on what you want to build. But it's important to understand that, as well as how you can now update yours or update your objects in a state, as well as array in a state. So with object, you always want to generate is a new state, period. And you use immer to make that update logic consistent in a mutable way, something that we are quite familiar, which is that. And then we look now at the updating arrays in state. Again, always return the new state with that particular mutation. For example, an insertion you can add in at the beginning or at the end of that collections, followed by the spread operator. And the spread operator, what it's doing is to evaluate if this syntax after the three dots is an iterator. It means that I can iterate through all of these elements as a way to add in all of these elements to this new array. Okay, it's like performing a for loop, but in behind the scenes is using, again, this is go beyond the scope, but it is important to just to mention that that exists. If you want to dive deep, it is good. So what happened is that the way of how now can we iterate through our elements is by using is a for loop, right? We are all quite familiar with that. Also perhaps with while, okay? Most of the time it's with for or while, all right? So the idea is that because most of the time when we are developing our applications, we only is to know is the data that is inside of each one of those elements as a way to work with them. We don't care too much about the iterative logic here or the iterative algorithm for that. We know how to do that. If you don't, you should. We know what to do, how to do that using for loops, while most of the time for loops, okay? But with the iterator protocol, it's a now it'll be very interesting as a way to, instead of actually be imperative, meaning we have to actually write the code of how to do the thing, which is something that I love. I really liked it. But now with this function that we can pass is a callback as an input, all right? In the case of high order functions, that kind of thing. But now this function will run as long as this object follows this signature, this batch, this iterator protocol. So if it is, okay, now we know first, it follow, if this object follow this particular iterator protocol, and I know this, I'm going beyond the scope of this course, it's just as a way to describe that. And if you're curious about that, I will invite you to take a look at some other courses, even though my own courses, on the async nature of JavaScript, where we explain that briefly as well as the higher order function. But in any case, so followed by the three dots, okay? These objects, which is an iterator, and as long as it's followed this iterator protocol or iterative protocol, you have an iterator, you have an iterable, what you define is the logic, the iterative logic, as well as the iterator, which is now an object that you return as a way to indicate, hey, this is the element that you're asking for anytime you run this function. In any case, so we move on. We also look at how can we remove an element using filter and return a new state from that. Okay, hey, I want you to know all of those elements whose ID is not the same like this, give it to me. All right, as well as how you can now apply some transformations to that. The TLDR of this is that how now can we update our state, how can we update objects and array in a state as part of now when we comes to build now more UI components, all right? How can we manage a state, because this is the main source of issue when you're starting to scale your applications. So that is first understand how to think in UI, how to think the UI changed. And I don't know, I don't know if, for example, Basecamp, I don't know if Basecamp actually, oh, of course, they're not using this React for that. Okay. Brought to you by the makers of Basecamp and Hey. And Redux. And I get it why people like this actually using is Redux for that. This is state management. Exactly. It's a library, it's a JavaScript library for predictable and maintainable global state. That's all. That works with anything as you can imagine. So it is not tied to one of it. So in any case, so as we look now at how the need of how to manage our state, how to organize or how to have a state structure, as well as how you can now create your, or how it's important to keep your state update logic, as well as how you can pass down data to different components. First, it's important to look at how to think UI change as state change, as a way to borrow concepts from the UI designers like wireframes and all of these different visual state, and think in terms of React when you're going to write your application. Which means is that identifying all the visual different state, identify all the visual different state, determine what trigger those state updates, and then that's one of the reasons why we have, for example, tools like xlate, I think it is xstate, okay, as a way to help us these JavaScript state machines and the state charge. You know, hey, it is now much more useful to see how one particularly UI elements go from one to another, you know. So it integrates well with React, Vue, Svelte, and other frameworks, and can be used in the front end, back end, or whenever JavaScript runs. Because after all, this is just a way of how you can orchestrate your state. It's a state management and orchestration solution. Pretty much like Redux, okay? But now here, the powerful thing is that you can now have a Visual Studio, which means that you can have now visualization of all of your state and how they're going to update. That's a very, very nice and interesting tool that can allow us to actually see all the possible visual state that our components can be. Then you determine then you represent those states. That's quite interesting because all of this will be automated all of it will be automated, which is great. Uh, then you see how now you can represent those states using a state, all right? And with that, um, avoid any non-essential state, and then you will now is connect your state, connect the event handler to update the state. This is a pretty standard way of how you're going to create your components. Also following is the thinking React way, as a way that you need the mock and the data, and then you're going to now break down the UI from there. Have now a static representation of your React components, of your React app, and then represent is the state or the minimal UI state, and then use the minimal UI to represent is the different states in these components. And I mention this because this is quite interesting. You know, find the minimal but complete representation of the UI, and then identify where your state should live, which is something that we're going to talk about that, and then add inverse data flow. And by the inverse data flow, it say, hey, now these children components will provide or have access or trigger is the state update for that. So, because we were talking is now how we can managing our state, looking at the React input, or know how to state updates. Yeah, know how to update our state, or how to think UI change as state change. All right. Then we look at how can we now organize our state structure, which is a concept now that they borrow from the database engineer, like database normalization, as a way to eliminate redundancy and duplicate data. And they come up with some principle here when they say, once you know the way of how you can structure your state is by grouping a state together, eliminate or avoid any contradictory states, any duplicate states. If you can get this data from the props or any another state, do that. Avoid any redundant states. Yes, avoid any duplication states as a way, because they are very hard to keep sync. If you have a state that is tracking another state, you have now duplicating a state. You definitely don't want that. It is very hard to keep them in sync. Avoid that. And the other is that deeply nested object in state. This is an incorrect term because after all of those objects, they just point into a property that contains or that hold that object. But in any case, then we look at how can we now live our state, or how can we now, as part of the way of how you can think in React, okay, thinking in React, as a way to now share that states across different components, all right? And how it's important to do that in terms of what will be the state that you want to share across different children components. First, remove the state children in those components if that exists, and then hard code the data with the props on the parent as a way to now see if that actually works as expected, and then do the inverse flow as they describe here. This at inverse flow is when you say, all right, now all of these children components, I'm going to now pass this event handler as well as the state, okay? And when that event handler is being triggered at the child components, at the parent, I want to now state or set the state update. When this is useful, you might wonder. Well, when you want, for example, is now sharing a state across different components. So for example, a filter and the search and the filter, all right? Also, if you want to create now a chat application, and the more you are, again, the more you um, the more inputs at a particular state needs to react, the more it becomes cumbersome to manage those states. So before going into that, and as we look at now, when you define your each unique piece of state, when you define that in your components, that component will own it. It means that it becomes the source of truth of others. So with this particular notion in context, as a way to now share our state across different components, I also look at how important it is to know which states and how React actually assign the state in the render tree. So the states are tied to the position in the render tree. Okay, you can think of this tree data structure actually contains some data that contains the state. So the state is tied to the position of the render tree, and by default, if you have the same components rendering in the same position at the tree, it will preserve the state. However, if you have different components at the same position in the render tree, it will reset those components. If you want to reset the same component at the same position in the render tree, you can use or show the component in a different position of the render tree, or use a key for that as a way to now indicate to React, hey, I want you to make use of this, okay? And want you to now keep track of all of this state or all of these components. They are unique. So I want you to now is anytime I toggle that or show something, reset that with the proper props that we want to pass them. This is a lot of jargon, by the way. A lot of jargon. When you can use that is, for example, when you're going to create is tabs, or in a chat application, or perhaps in a dashboard, where in this dashboard you actually click here and you want to now reset the state of this component. For example, when you click here, you reset the state by passing the data to this. When you click here, you reset the state again, and so on and so forth. And you might wonder how you can do that, all right? And because the more a state needs to react to, the more input a state inputs, whether it's computer or human inputs like typing or navigating to a URL, in computers like getting data from a server, waiting an image to load, whatever the input it'll be, the more inputs a state needs to react, the more cumbersome it becomes to. So that's why we have, for example, reducer functions as a way to make our update or state update logic simple. So that's quite interesting. That's in fact very interesting, because this is just a function that receives a state, and this is a function that receives a state and followed by the an state, okay, that receive an state and an action to generate a new bit of state that actually tells to React, hey, I want you to now is update this state. So as we now look at how can we do that, and how useful is to actually, when you have this UI selection pattern, use the ID or the index that must come from the ID from the backend. For example, selections like toggle into multiple checkbox or radio buttons as well. So when you do that, all right, the idea is that you want now to know how you can, is for example, pass data to different components as a way to now knowing how to manage or escape or state. And because using context, the problem that it solves is that it's now avoid is this prop drilling, meaning that you're passing down data through all of these child components. If any of these components for some reason is removed from the DOM, you lost the link, so you just down. So to prevent that, we have now a centralized place, aka a context, where we can now is to provide to these the subtree, the position at the DOM where we define them, and all of these subtree elements, and wherever the subtree will benefit to actually access that data. All right. You don't want to overuse context. Before using that, evaluate if you can pass down data to as props, or if you can now extract your component into a GSX element as a way to pass down data. And this is something useful as a way of how can we now create a context by creating is a context, and then so create a context allows or use the context in the component from the component needed, and then provide that context, that data. All right. And this is useful, for example, small app level data. So for example, analytics, authentications, theming, or when your state update logic needs to deal with a lot of inputs. So it makes sense to actually have now this thing called context. So now in context, there is a caveat here. That is, this is something that a lot of people actually mention in a lot of this interview, is that the more you're doing, so why we don't use is context. Again, we can use context, but for a small app level data, as I mentioned before. But the problem is that React will re-render all children's that use that particular context starting from the provider, that value change. So if that provider is at the top or is higher in the render tree, so now all of those components that using the use context, that context, React will now call them and re-render if the value of the provider change. So to avoid this kind of behavior, okay, that's why we use is some optimization techniques with not only use is or this the combination of the reducer and the context using memo and callback as a way to say, hey, let's go to, if we're going to define is the use reducer first, if we're going to use context with reducer, let's go to define is the context when there we create is the context for the state, then the context for the dispatch, okay, something that we're going to now use as a way to provide them in the exporter functions, followed by the children elements that we're going to receive as a props and then pass down. And inside of that render function, we're going to now set is the state and follow or using the reducer, okay, uh, and then use Memo as a way to say, hey, I just want you to now compute or calculate or update this value, giving a particular element that we receive from or that we are listening to, right? Uh, and I want you to now is dispatch this function in the reducer. So dispatch this function. No, use context like that, like so. And I just want this to and I want you to now do not re-render that. So for example, use callback is the store credential and set current user. All right, I want you to now run this only once. So for example, the dispatch, all right, if you want to return some of this particular function for that. And using now Memo as a way to catch that value. Okay, so hey, I just want this to now is catch this value. So using Memo as a way to catch this state, and use callback as a way to avoid or to catch this function between re-renders, because that's the terminology. Use Memo as a way to catch this computation between re-renderings. You can also pass an array of dependency, or use callbacks as a way to catch this function reference between re-rendering, and only runs that giving an array of dependency. And I think this is quite interesting. Totally interesting, by the way. Yep. Because now that leads us is to, okay, all right, to the what happened once we know how to scale our application using this React and creating all of these components and that kind of thing. So how can we now is learn? How can we now is, for example, synchronize with external systems? Synchronize or control with external systems. How can actually we do that? So by using is the use ref, which is the way of how you can remember things or remember information without re-rendering or triggering a re-rendering. So ref are useful. You can think of this as a secret pocket. We can add or store some object or some data here in or under the current object, okay, using use ref. So do not use this between re-rendering, okay, or in other words, is that when you're updating your state, because React doesn't keep track of this, and use this, for example, as a way to hold a reference of the time of ID, or to manipulate its DOM elements, or an object that is not relevant during the GSX calculation or the rendering code. So we look at how can we use now this use ref to manipulate them for a specific use case. For example, you want to now control is external system. For example, you want to now focus the input using the browser API or the scrolling. And we look at how can we do that using is the ref, again, as a way to control this element. And now the TLDR of that is that when this use ref is attached in the rendering mechanism, is when after the rendering, okay, and yeah, after the rendering. So the ref of current So before updating the DOM, okay, so before updating the DOM, or before the commit phase, now React is set the ref.current value, and after this screen updates, meaning after the commit phase, it's like, okay, now let me actually React assign the proper value of the DOM, if you're using the DOM, to that. And this is something important to actually understand, because now that leads us is to move on to this thing called effects, and how effects and event handlers are different as a way to, when you have your React components, you have two type of logic. Okay, so you have two type of logic inside of your React components. You have the rendering logic that must be pure, and this is when you describe the UI, and the other is that adding interactivity on your event handlers, which is something that you can now, for example, is perform some side effects like sending an HTTP post to the server, okay, connecting to a remote server. And because of that, this effect, or this side effects or function that run outside of the React components as a way to control and synchronize with external systems, it's a, well, I'm going to now run this effect as a cause of I'm going to run this effect or this piece of code that are caused by rendering itself, not by a particular event. So the event here is when the components render itself. That's why when you are using effect without with just only passing as the first argument a function, that code which will execute it is after the screen update, meaning after the commit phase, okay? Similar to the useRef. The useRef is created before the DOM updates and then assigned after the DOM is updated. And now the useEffect, which is this side effect or piece of code that you want to run cause by rendering itself, this component, running that function or running that code is happening after the commit phase. So that's great as a way to now organize our mental model completely. So because of that, now we look at how can we actually write this effect, which is exactly what we're going to do in today's video. All right, let's get into this. Let's get into this. You know what? Let me stand up. Stand up, stand up. Stand up for your life. Pim, 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 stand up, stand up. Don't give up the fight. Don't give up the fight. Stand up, stand up. Stand up for your life. Stand up, stand up. Don't give up the fight. No, 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 no. Stand up, stand up. Stand up for your life. Stand up, stand up. Don't give up the fight. No, 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 no. Stand up, stand up. Stand up for your life. Stand up, stand up. Don't give up the fight. No, stand up, stand up. Stand up for your life. Stand up, stand up. Don't give up the fight. No, 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 no. Stand up for your life. Bing, bing, bing. Stand up, stand up. Don't give up the fight. Give up the fight. Stand up, stand up. Stand up for your life. Stand up, stand up. Don't give up the fight. No, 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 no. Okay. Put it dark mode. Okay. So, now that we know when the effect is run, as well as when the use effect is added, we have now this mental model of the render mechanism. Now we are going to look at how to write your effects. Okay, and you might not need an effect, which is, I think, this is something that again, even though that Brian Hall described that, is that if we want to have a happy life as a React developer, 99% of that, even though this is something that I would like to do, React here. No, this is intro, complete intro to React. Now, if you want to have a happy life with that, okay, especially with effect. Let's say exactly useful to illustrate is this. And now we understand what is creating that hook. Yep, we understand it's the mechanism. I didn't have it. If you want happy, exactly. There you go. Long-term maintainable React code value proposition. Secret for writing long-term maintainable React code. The hardest part of React is use effect. The most book you're gonna see, the most confusing things rapping about when does this event happen? When does this event happen? And does this cascade into other effects? So Oh my God. Is the most cognitively burdensome part of React use effect. So explaining to someone in our case about how breeds get updated in several sentences. So the nice things of React Query is that you're going to start moving effect from your database because it basically handles all of your API requests, minimizing effects in your code, and this is very loose rule. Okay, minimizing effect in your code. This is a very loose rule from Brian Hall. If you need to use effect, try to contain them into a small testable areas. Remember that at the end of the day, effects are just this small piece of code, side effect that you want to synchronize with external systems, the browser API, third-party libraries like jQuery or MapLeft, or connect to a remote server and listen from events or from message. Okay, you want to make this code uh, self-contained. Okay, try to contain them into small testable areas, aka creating is abstraction for them. This is the secret to a long happy life, with React. And I don't know why you put that. With React. So 95% of the use effects are for handling API requests. All right. And that's one of the reasons when you combine what you have read and what you have here. So perform optimization with React Query, performance optimization with React Query as a way to now handle this particular logic. Again, there's nothing wrong with the words that Brian Hall actually described in this particular course, which to me is quite great. Okay, but well, we need to, in fact, is take a look at how you can write your effects and what is the anatomy of the effect, and followed by the use cases. So the way of how you can react your effect is by defining is is by defining is or by describing is declare the use effect. Remember that this will happen after the screen updates, and it happens by default on after every commit. Okay. If you specify the effect dependencies, which is something that you most of the time want to do that, because we 95% of this we use that for fetching data. So rather than after every render, here you can now indicate when you want this piece of code runs. And when you want now, for example, you want to use the array of dependency, if you need some of this dependency, how you can now make use in that particular code. So React is not only is with use effect, which you can think that is behind the scenes is using a closure. It not only is storing that code in a persistent place, as well as the array of dependencies, as well as it is reference for that. So that's quite interesting, because then add some cleanup if needed. Some effect need to specify how to stop, undo, or clean up whatever they were doing. For example, connect need disconnect, subscribe need unsubscribe, and fetch need either cancel or ignore. So once you declare your effect, that by default it happens after every commit, and you define the array of dependency to tell them when you want to the effect run. Okay, and this is what caused the most cognitive burdensome, or the most cognitive load, because now you are going to see that well, this effect in this piece of code, you want to know is when this happened, and does this cascade to another effect? In other words, is this side effect, is this code that we're running, is actually cascading to other side code or other code for that. So that's quite interesting. I get it. So for example, when you have now the rendering phase, and by passing all of this code that happened at the after the screen updates, all of these things, you want to know is when of all of this cascade to another effect, or they are dependent of that. So that's quite interesting of having that mental model there. Totally. All right. Okay. Cool. Totally cool. Because now, because now with that, after we declare an effect, and how now we can is to interact with the effect as a way to now hold the reference to synchronize with external systems like this. Hey, I want you to now run this particular code on every rendering here, which is something that we did here. Hey, when these components render, I want you to now have at the end of the after every commit, run this code. You know, you need to know when this code actually happened. After every commit render, after every commit phase, because we having specified is the array of dependency. However, when we specify now, because this is actually triggering on every render, on every when this function is called every time here, as part of the state or the variables updates here, you can see, for example, here like, hey, console log is source, or I say is plain, right? So anytime now here, and it's funny because since this is in a strict mode, React actually call all of or rendering all of your components twice as a way to identify if there are any what is this strict mode. Okay, as a way to find common bugs in your development. Exactly, your component will re-render an extra time. Your component will rerun effects an extra time. And your component will be checked for uses of deprecated API. So, in other words, is that this, as a way to prevent some common bugs, is going to re-render an extra time, reruns effects an extra time, which is this. That's one of the reasons why you see this. They're using it as a strict mode, as a way to prevent any common bug, and check if you are using deprecated APIs. So that's one of the reasons why we have this twice. So now, because this is plain, okay, when this change, okay, it means that when we set the state at this level component, it'll also going to now not only because here in this pattern component we actually set the state update, we're triggering or we tell React to render this, pass through the rendering mechanism, trigger render, and when it renders it is evaluating or calculating all of this, okay, and if this function return exactly is calculating all of this, hold that information from the next phase, and then if the return contain is a React component, it will call that, which means that it will now render this, compute this, the props, the ref, and all of this. So compute that, calculating that, aka it means that it's going to render this use effect. But it will render, or it will call this use effect after the rendering happens. So after the rendering ends, and now it creates this virtual DOM where now it's going to reconciliate this using the Fiber, the reconciliation engine for that of React, and then apply the necessary DOM updates to that. Once the screen updates, now React say, let me now actually run all of this side effect, all of this code that is under the effect, under the use effect. And of course, it will trigger only once here. You know, hey, that changed. Hey, we're calling that. And we're calling again. And we're calling again. And we're calling again. And again. And again, you know. Because effectively, when we set the state here, we are now is calling those renders components under the render subtree. If they change, okay, as long as they are different between rendering, and of course, they are different between rendering. So, for example, here you say is you say source like this. Because, and it is funny because source doesn't change, but the component itself change is different. It's playing, for example. So let's go now to make this. Okay. So let's now going to do is this. There's a way to run is this. And see this, right? So I want you to now render here, and it's render as it is, right? So because it's interesting, it is being called because we are rendering that component, and that to me is quite interesting. That to me is quite interesting. Let me reset this. Oh, but it's like, what the F are you think you're doing? Look at this. Okay, you get stuck. You get stuck. I love it. I pretty fucked off that. Exactly. And even though that we are changing here, we are not going to actually say this. We're not going to pass this is that. Okay. So I'm going to now refresh this and say, hey, I want you to now, exactly. But in theory, you shouldn't is call that component. But the funny thing is that it does. Even though that this component is not different, but it's because it's calling that. It's because it's calling that reference. That's the pretty fucked up thing of all. The code is being run, but you don't know if this is this. So the state is being run. So for example, video logic rendering, which I'm assuming that it shouldn't, even though that we are calling that, which to me is quite interesting, that this is being called. So when I click here, and it is called, which means that it's evaluating this. That's quite fucked up. So, because at the end of the day, it is interesting because anytime you define here, you actually tell it to react to call this component. That's quite interesting. That to me is quite interesting. You know, catching rendering in React. A veces no. Avoid re-rendering React. Exactly. Use cover, use memo, but use memo. Let you catch the result of a calculation between rendering. Okay, but it's interesting because now you're going to have much more fine control about, oh my god, so you're gonna have is much more fine control of when this is being run, because at the end of the day you are indeed calling this render function, this render code. What you want is to catch is the state or some function callbacks from being called. Oh, okay. And by default, it is being called as it is. So anytime it actually now re-renders, you're gonna call that render logic. So for example, if I tell you now using Memo here, hey, I want you to know is this, all right? Calculate value, or you say is use callback, and here you're gonna pass it some function here. Exactly, some function and the dependencies. Okay. So if the source is different, of course I want you to now run is this and say, hey, I want you to now is render this. For example. So when you reset this, oh, Okay. Because you need to use that in there. Okay. So now this function, but it's being run as part of this. So for example, if we say now is playing, because that code is getting called on every rendering, it's funny because this particular code is being called on every render. So if, for example, if we say, hey, I will only just to do that when the source change, okay, you know, this code will only run is when the source change, which is great, which is part of that. Specify the effect dependencies like this. So instead of using it as a ref, which is after all, we want to skip unnecessary rerunning effect, we can safely do that as it is. So it's playing for that, and this is actually how can we prevent that. So why was ref omitted from the dependency array? Because you will always get the same object from the use effect, from the use ref call on every rendering. It never changed because it remembers that. And so this is a place where you can safely do that. Omitting always stable dependency only works when the linter can see the object is stable. And step 3, add cleanup if needed. Right? So because I just want to run this code only once, okay? And this is the effect only runs on mount, so you might expect the connecting to be printed once in the console. However, if you check the console connecting get printed right, why does it happen? Well, because now here you are in the strict mode. You are in the strict mode. Bugs like this are easy to miss out when without extensive manual testing. To help you spot them quickly in development, React mounts every component once immediately after it is initial mount. So this strict mode helps you to solve some common problems, which is might be useful or not. It can cause that your application slow in development because it's now calling, it's now re-rendering all of your components twice, as well as calling your use callback twice. So that might not something that you want. But the alternative exists. Okay. To fix this issue, return a cleanup function from your effect, like that. So now you get 3 console login development, which is once you evaluate this, and the other is when the disconnection, when you now remove that. Okay, React will call your cleanup function each time before the effect runs again. And one final time when the components on mounts get removed. Let's see what happens when cleanup function is implemented. This is the correct behavior in development, because now it's actually doing that properly. And when you see this, it say, hey, I'm running your effect twice as a way so you can see that there is no problem or any cleanup. You can now actually prevent some most common gotchas here. So in production, you will only see connected, printed once. Remounting components only happen in development to help you find effects that need cleanup. You can turn off strict mode to opt out of the development behavior, but we recommend keeping it on. This lets you find many bugs like the one above. How to handle effect firing twice in development. React intentionally remounts your components in the development to find bugs like in the last example. The right question isn't how to run an effect once, but how to fix my effect so that it works after remounting. Again, the React way. Usually the answer is to implement the cleanup function. The cleanup function should stop or undo whatever the effect was doing. The rule of thumb is that the user shouldn't be able to distinguish effect between effect running once in production and setup, cleanup, setup sequence as you see in development. But again, with effect, your setting is that setup, cleanup, setup sequence. Most of the effect you will write fit into one of the common patterns. Most of the effect you will write will fit into one of the common pattern below. Okay. So you get now is controlling non-React widgets. Okay. Sometimes you need to add UI widgets that aren't written to React. For example, let's say you're adding a map component to your page. It has a set zoom level method, and you're likely to keep the zoom level in sync with a zoom level state variable in your React code. Your effect will look similar to this. So this is now how you, controlling non-React widget. For example, is maps. Okay. Controlling non-React widgets. Note that there is no cleanup needed in this case. In development, React will, this is the most common pattern. Okay, most of the effect you will write will fit into one of the common pattern. Will fit into one of the most common patterns. Controlling non-React widgets like this is like, hey, I want you to know. For example, this is something that you're going to do a lot, bro. Especially this integration. Totally. Controlling non-React widgets. Know that there is no cleanup needed in this case. In development, React will call the effect twice, but this is not a problem because calling set twice with the same value does not do anything. It may be slightly slower, but this doesn't matter because you won't remount needlessly in production. Some API might not allow you to call them twice in a row. For example, the show model. or in a dialog method of the built-in dialog element. Throw if you call it twice. Implement the cleanup function and make it close the dialog. What the F is this? Show model. What the F is this? The show model method of the HTML dialog element. Okay. Dialog element. Opening a model dialog sample. Okay, it's like showing dialog.open. What in the F? Now you got is this HTML dialog element from the HTML? Holy moly. Related page for the HTML done. You have HTML anchor element, something like quite familiar. Area, audio, HTML element, input, iframe, map, blah blah blah, script, time, history, image, data, message, and we also have the dialog. This is new. This is new. Div, HTML div elements. Okay. And then you get exactly to manipulate interface provides special property beyond the regular HTML interface for manipulating div. And now you got the dialog here. Inherit property and method from the HTML. So you have now a form, method, dialog. Holy moly. Opening a model dialog. Okay, opens a model dialog. There is now a dialog element here. What in the F is this? What in the HTML only display sample? Creating a model. Holy French toast. You can create a model here. Show the dialog. And close the what? What? Background image linear. And it is funny because it takes all the available space in dialog. And it centers that. What? The handling the return value from the dialog. Okay, you can what? Show the dialog and favorite animal. Bring shrimp, red panda, spider monkey confirmed. Return value spider monkey. If you cancel this, can I cancel this? And return value. What in the F? But it's using form method, closing a dialog with a required form input. With a required form input. And the using here is exactly a form for this. And show dialog. Show model. And the other is that using a form to show that. What? Normal close, non-validate close, GSS close. What? GSS close. Add event listener click, prevent default dialog close. What? And the dialog here is this, because it's a dialog, and it has exposed that. What? Okay. Okay. In development, your effect will call show model then immediately close and then show model again. This has the same user visibility behavior as calling show models once and you see in production. Your effect will call show model, then immediately close and then show model again. But this is if you want to control a non-react widgets. The other is subscribing to events. If your effect subscribe to something that the cleanup function should be unsubscribed. In development, your effect will call again if you want to have a happy life as React developer, okay. Okay, if you want to have a happy life as React developer, okay. If you use effect twice, find the sweet spot between readable component and minimal set of components. Long-term maintainable React code. Minimize effect in your code, and this is a very loose rule from Brian Hall. Exactly, minimize effects in your code. Read as less effect possible. If you can't, so self-contain that into their own functions here. So subscribing to event in development, your effect will call it add event listener, then immediately remove event listener, and then add the event listener again, the same handler. So there will be only one active subscription at a time. This has the same user visible behavior as calling add event listener once as in production. Trigger animation. If your effect animates something in the cleanup, okay, triggering animation. If your effect animates something in the cleanup function, should reset the animation to the initial state. In development, opacity will be set 1, then to 0, and then 1 again. They should have the same user visibility as setting it to 1 directly, which is what will happen in production. If you use a third-party animation library with support for twinning, your cleanup function should reset the timeline to its initial state. And then you got fetching data, something that we're quite familiar with. If your effect fetches something, the cleanup function should either abort the fetch or ignore it as a result. You can undo a network request that are already happening. But your cleanup function should ensure that the fetch that's not relevant anymore does not keep affecting your application. If the user ID changes from Alice to Bob, cleanup ensure that Alice response is ignoring even if it arrives after Bob. In development, you will see 2 phases in network tab. There is nothing wrong with that. With the approach above, the first effect will immediately get cleaned up, so it is copy of the ignore variable will be set to true. So even though there is an extra request, it won't affect the state thanks to the if ignore check. In production, there will only be one request. If the second request in development is bothering you, the best approach is to use a solution that deduplicates requests and catch the response between components. Use some data library to do here. This will not only improve the developer experience, but also make your application feel faster. For example, the user pressing the back button won't have to wait for some data to load again because it will be catch you. That's one of the reasons why it's being for data catching, for data fetching, use query. What are good alternatives for data fetching? Writing fetch code inside Effect is a popular way to fetch data, especially in fully client-side app. This is, however, a very manual approach and it has significant downside. Effect don't run on the server. Why they don't? Because they don't implement the fetch. This means that the initial server rendering HTML will only include a loading state with no data. The client computer will have to download all the JavaScript and render your app only to discover that now it needs to load the data. This is not efficient. Fetching directly in Effect make it easy to create networks waterfall. You render the parent component, it fetches some data. Render the child component and then starting fetching the data if the network is not very fast. This is significantly slower than fetching all data in parallel. Fetching directly in Effect usually means you don't preload or catch data. For example, if the component unmounts and then unmounts again, it will have to fetch the data again. It is not very ergonomic. That there is quite a bit of boilerplate code involved when writing fetch calls in a way that doesn't suffer from bugs like race condition. This list is a downside. It's not specific to React. It applies to fetching data on mount with any library. Effects don't run on the server. But because it's part of the React rendering, exactly, because it's part of the React, which means is that, oh my god. So the browser needs to, so this means that the initial server rendering HTML will only include the loading state with no data. The client computer will have to download the JavaScript and render your app to only discover that it needs to load the data. You know exactly when it renders. So on the initial request, it has the HTML, but they now make another request to actually fetch the React component or the JavaScript code that actually render that, only to discover that now it needs to load the data. So you need to actually make another request. Holy shit, this is not efficient. Fetching directly in Effect make it easy to create network waterfall. Fetching directly in Effect usually means you don't preload or catch. It's not very ergonomic. This list of downsides is not specific to React. It applies to fetching data on mount with any library. Like with routing, data fetching is not trivial to do well. So we recommend the following approach. If you use a framework, and they now recommend you a couple frameworks. If you use a framework, whether it's Next, Remix, Gatsby, or Expo for native apps, bleeding edge frameworks, or Next.js app router. Next.js app router is a redesign of the Next API aiming to fulfill the React team's full stack architecture. They're gonna move to that, bro. You like it or not? Vision. It lets you fetch data in an asynchronous components that run on the server or even during the build. Next.js is maintained by Vercel. You can deploy Next.js app to any Node.js or serverless hosting or to your own server. Next.js also supports static export, which doesn't require a server. But again, Next.js app router is the redesign of the Next.js API, aiming to fulfill the React team's full stack architecture. All right. Okay. So if you use a framework, use its built-in data fetching mechanism. Modern React frameworks have integrated data fetching mechanisms that are efficient and don't suffer from the above pitfalls. Exactly. Use the built-in data fetching mechanism. Otherwise, consider using or build a client-side catch. Popular open source solutions include React Query, Use SWR, and React Router 6.4 or greater. You can rebuild your own solution too, in which you will use effects under the hood, but add logic to the duplicating requests, catching response, and avoiding network waterfall. There is a lot of going on here. The duplicating requests, catching response, and avoid network waterfall by preloading data or hosting data requirements to routes. You can continue fetching data directly in effects if neither of this approach suits you. The other is sending analytics. Holy moly, for data fetching, it is better to use is React Query, even though they tell you that, the documentation recommend that. Use SWR, which is stale while revalidate. This is a React hook for data fetching. Stale while revalidating. If this is error, yes. If this is loading, yes. And they have is a hook behind the scenes as a way to now synchronize with all of this state for that. Sending analytics. Consider this code that sends an analytic event on the page visit. In development, log visit will be called twice for every URL. So you might be tempted to try to fix that. We recommend keeping this code as is. In development, log visit, send a post request, will be called twice for every URL. You might be tempted to try to fix that. We recommend this code as is. Like with early examples, there is no user visible behavior difference between running it once or running twice. For a practical point of view, log visit should not do anything in development because you don't want the log from the development machine to skew the production metrics. Your components remounts every time you save its file, so it log extra visit in development anyway. In production, there will be no duplicated visit logs. To debug analytics event you're sending, you can deploy your app to a staging environment, which run in a production mode, or temporarily opt out of strict mode, and it is development only remounting check. You may also send analytics from the route change event handler instead of effect. For more precise analytics, Inter-Server Observer, which is an API, can help track which components are in the viewport and for how long they remain invisible. Not an effect, initiating the application. Some logic should only run once when the application starts. You can put it outside your component. This guarantees that such logic only runs once after the browser loads the page. Not an effect, initializing the application. Of course, not an effect initializing the application. Not an effect buying a product. Run this effect file twice in development, exposing a problem in the code. When you're gonna fetch data at the end of the day. Buying is an event. Of course, exactly, when you want to send data to that, because buying is an effect, is an event, not an effect. So if you want to send data, okay, delete an effect and move to API buy request into a buy button event handler. Makes sense, because you don't want it to send data on an effect. You want it to send a get request. This illustrates that if remounting breaks the logic of your application, this usually uncover existing bugs. and putting all it together, fellas. Good. All right, that was quite interesting, by the way, because now we were able to see not only what effects are, what is the difference between an effect and an event, how can we describe that, the rendering logic, which is part of the describing UI on the React docs, and which is that your code must be pure, they must run pure code, followed by the followed by the event handler code, adding interactivity. So effect runs as cost of rendering itself initially. So because most of the time we don't want that behavior, we look at how can we write our components, or how can we write our effects, and you might not need an effect after all if you are depending on a state, okay? And the way of how you can create your effect as a way to synchronize with external systems, for example, is analytics, or a server, or this is the most common, okay, the most common pattern. For example, analytics, a server, a widget, jQuery, or any map from that, or subscribing to an event for data. Okay, that makes a lot of sense. So we look at how can we write that by declaring is the use effect, and then it is dependency, because you don't want to this code that will run after every commit phase, execute that. All right, that's why you pass this on dependencies, and therefore you now want to clean up if needed. So so. Putting all together. So, and after that, I also look at the cleanup phase. Okay, as a way to, for example, when you need to clean up your state. Yep. As a way to, for example, need to clean up the state. All right. As a way to, for example, you need to unsubscribe to an external system, close the connections, or unsubscribe. Okay. So the most common, we also look at how to handle this effect firing twice, because React 18 uses strict mode. You can put it or not, but the idea here is to prevent you to prevent you to fix some common problems during rendering your logic and calling your effects. Okay, so that's why it actually run this twice, and how you can now see most of the effect you will write will fit into one of these patterns below. So most of these effects you will write will fit into one of these common pattern below. Okay. Most of them. Okay. Most of them. Most of them. All right. So most of the effect that you will write will fit into one of these common patterns. Whether it is controlling non-React widgets, JavaScript widgets, a map, jQuery, so controlling non-React widget. And for that, there is no need to actually return is a cleanup function. Subscribing to events, so for example, subscribing to a server from listen to a chat message, or subscribing to an event, you have to need the subscribe and unsubscribe phase, okay, as a way to now clean up that. So hey, when this component is removed or is unmounted, I don't want you to actually run that code. Okay, are we sure about that? Because React will call your cleanup function each time before the effect runs again, and one final time when the components are mounted, get removed. Okay, let's see what happens when the cleanup function is implemented. So in production, you only see the connecting, print once. Remounting components only happen in development, so you will find effect that cleanup. Again, so the idea here is that we're looking at how to handle this effect firing twice, because now a strict mode is mounting your components as a way to prevent some kind of issues in during rendering your components or your effects, okay, as a way to come on some common gotchas in your code. All right. Okay. Makes sense. Makes a lot of sense. Makes a lot of sense. Makes a lot of sense. So the effect, most of the effect you will write fit into these categories. Most of the effect you will write fits in those patterns. Or you write your effects to connect or controlling non-React widgets. For example, a map. There is no need to actually clean up that or return something unless you're using is the DOM the DOM dialog. Okay. The other is triggering subscribing to events. You will need to have a you will need to have a phase to adding the event, and on the cleanup remove that. My question is that with effect, that cleanup phase, okay, for example, cleanup phase, and setup and optional return. Use effect returns undefined caveat. Use effect is a hook, so you can only call it at the top level of your component, no problem. So you can call it inside of loops or conditions. If you need that, extract a new component and move that state into it. If you're not trying to sync with external system, you probably don't need an effect. You know, if you're not trying to sync with some external system, you probably not need an effect. When strict mode is on, React will rerun extra development only setup plus cleanup cycle before the first real setup. This is a stress test that ensures that your cleanup logic mirrors your setup logic, and that it stops or undoes whatever the setup is doing. If this causes a problem, implement the cleanup function. Synchronizing effect. If some of your dependency are object or function defined inside of the component, there is a risk that you will cause the effect to rerun more than once. To fix this, remove unnecessary object or and function dependency. You can also extract state updates and non-reactive logic outside of your effect. If your effect wasn't caused by an interaction like click, React will generally let the browser paint updating screen first before running your effect. If your effect is doing something visual, for example, positioning a tooltip, and the delay is noticeable, use layout effects. Because again, this code is run after the browser paints the screen. React will generally let the browser paint the update screen first before running your effect. If your effect is caused by an interaction like a click, React may run your effect before the browser paints the updated. It may run. Why may and not do that? Even if your effect was caused by an interaction like a click, React may allow the browser to repaint the screen before processing the state update inside your effect. Usually this works as expected, however, you must block the browser from repainting the screen. You need to replace use effect with use layout. Use effect only run on the client. They don't run during server rendering. Because after all, this is a code that is running using JavaScript, but for that you need is to effect only run on the client. They don't run during server rendering. Okay. All right. Okay. That's good. So my question is that with the cleanup code here. Exactly. This is the cleanup code. After every re-render your component where the dependency have changed first, your cleanup counts runs with all props and state. Then your setup code runs with the new props and state. Your cleanup code runs one final after your component is removed from the page. Exactly. This is what I want to know. So this cleanup code is run after your component is removed from the page or unmounted. Okay. So now slowly to make sense of all of this. Slowly but steady. So this code will run is after a component is unmounted. Okay. Your cleanup code, exactly. One is you need to pass two arguments to the user effect. A setup function with setup code, okay, that connect to that system. And it is interesting because they are only focused for connection to external system. Period. A setup function with setup code that connect to the system, it should return a cleanup function with cleanup code that disconnect from that system, a list of dependency including every value from your component used inside of those functions, which will be values that will be used inside of those functions. And React call your setup and cleanup function, whenever it is necessary, which may happen multiple times. Your setup code runs when your component is added to the page. So when your component is mounted, the setup code is run, which means that when this component is not only mounted, but also after every re-rendering. after every re-rendering of your components where the dependency have changed. If there is no dependency, it only runs once. First, your cleanup code run with all props and state. Run with all props and state. And then your cleanup code runs a final time after your component is removed. So if this component is removed, the cleanup code is, so if this component is mounted, it will run the setup code, okay? And it should return a cleanup, it should. It should return a cleanup function with cleanup code that disconnects from that system. The other is a list of dependency, including every value from your component using inside of those functions. And then your React calls your setup and cleanup function whenever it's necessary, which may happen multiple times. It can happen at when the component mounts, okay, or after every rendering, okay, where the dependency change, or only once if the array of dependencies is empty, okay. So after every re-rendering of your component where the dependency have a change, you say first cleanup code, run with all props and state, and then your setup code. Your cleanup code runs one final time after your component is removed from the page. And when this component is removed from the page, it will call this function because it is after the commit phase. After effects are run after every commit. After every commit. But again, this is now the anatomy of how this effect mechanism work. All right? Okay, and that is when we're getting here as a way to connect with an external system, whether it's a widget, subscribe to an event, or to a remote server, or to trigger animation connected to another external system, sending or fetching data as well, as I mentioned here, fetching data or sending analytics, which is another system, okay, it will do the following, okay. When this component is mounted, it will call the setup code. If this effect was after every re-render of your component's dependency, after every re-render of your component where the dependency have changed, now we say let me run the cleanup code and then the setup, the cleanup code with all props, and then the setup code. And you're going to run your cleanup code when the component, exactly, your cleanup code runs one final time after your component is removed from the page. And let's illustrate this sequence for the example above. Listen to a global browser event. For example, triggering an animation. Exactly, connecting to external system, fading animation as a widget, controlling a model dialog. That's to make was it's like that. It's like you can now is show that or close it, bro. You know, show it in tracking elements of visibility. Tracking element visibility. Wrapping effect in custom hooks. Exactly, wrapping effect in custom hooks. Controlling a non-React widget. fetching data with effect. But instead of doing that, they prefer to go with or with using React, the React query for that. That makes a lot of sense. Or using some of these full stack applications or these frameworks like Next.js that allow you to now fetch data without all the drawbacks. Specifying reactive dependencies. Updating state based on previous state from an effect. That's right, updating state based on previous state from an effect as a way to keep track of this. But instead of, because what happening is that you are effectively are creating is a loop here. Because what happened here is that it will at the initial render it's gonna set this you're gonna return the cleanup function, okay, and then you want is to pass this the count for that as a way to keep track of this. But there is no need for this. But specifying count as a dependency, always reset the interval, because you're running is this code again. So since count is a reactive value, it must be specified as a list of dependency. However, that causes the effects to clean up and set up again. It clean up here, and it clean up the interval, because it first run the cleanup here, and then the code here, which means that set the count will be is after 1 second is 0. So to fix this, pass this as a state updater for that. So pass a state updater. Updating a state based on previous state. Updating a state based on previous state. On count. Exactly. If you update it before like this, so now you are dispatching sequence of state. Because if you do this, you are now calling is this, but it's, yeah, okay, this is not ideal. However, that caused that effects to clean up and set up again every time the count changes. Because every time the count changes, we're going to clean up and set up that. Clean up and set up the code. Clean up and set up the code. But in fact, what we can do is, instead of doing that, we can is now update this state here as sequence of state updater. Like this, because now your one is to send a sequence of a state update. Updating is that. Updating state based on previous state. Updating a state based on previous state, and I remember that. Exactly, I remember that from here. Updating a state based on previous state. which is queuing a series of state updates. Okay, I didn't know that you can do this on Effect. Okay, now things is starting to make a lot of sense when you do that. Okay. Okay. As a way, it's a series of state updates. So now this will call, and you are now is updating is a series of states here, running this code, which is a JavaScript function that is interacting with external system here. Okay, and this code you're gonna say, hey, I want you to now is, well, this will run every time the count change. In fact, it will run is on the initial render, oh my god, and then update the state based on the previous state. Here, by saying now this piece of code that I want you to run is after every commit phase, in this case only once when this component is mounted, what you're gonna do is to run this code only once. So you set the interval that the setup code, you set the interval that, and as a way of how you can now update a sequence of states, this is how you can do that. Passing a state updater. This is how you can now update a sequence of states updates based on its previous value. And now here you effectively have is that. And when these components are mounted, React calls the cleanup phase, and that's it. So your effect no longer needs to depend on count. As a result of this fix, it won't need to clean up and set up the interval again every time the count changes, removing unnecessary objects dependency. If your effect depends on an object or on a function created during rendering, it might run too often. For example, this effect reconnects after every render because the object is different for every render. No, but this is okay, but that was quite interesting as a way to put a practice all of these different concepts and how that actually fit in our and how that actually fit in our logic here, which is great. Holy moly, god damn it. All right. All right. That'll be all for this video. Take care. Bye bye.